Imagine a ladder that stretches from the first spark of chemistry on a barren rock all the way up to a civilization capable of crossing the stars. Every species in the universe must climb that ladder, step by step, from simple molecules to cells, to complex life, to intelligence, to technology, to the cosmos. But here is the thing about that ladder. Almost nothing makes it to the top. Somewhere on that ladder, there is a rung that almost every civilization fails to pass. A barrier so difficult, so catastrophic, that it has silenced world after world across the universe. Scientists call it the Great Filter. And the most terrifying possibility of all is that we haven't reached it yet. In our last video, we explored the Fermi Paradox, the unsettling silence of a universe that should, by all statistical reasoning, be teeming with intelligent life. We asked, where is everybody? One answer, perhaps the most consequential answer, is the Great Filter. The idea that something, somewhere along the path from chemistry to civilization, acts as an almost insurmountable wall. And that the universe is quiet not because life never starts, but because something keeps stopping it. The concept was formalized in 1998 by economist Robin Hanson, but the implications reach far beyond economics. They touch on everything: our past, our present, and the probability of our future. There are two possibilities. Either the Great Filter lies behind us, or it lies ahead. Everything depends on which one is true. To understand the Great Filter, you need to understand just how many steps separate a bare rock from a spacefaring species. Step 1. The right star in the right location with the right chemistry. Our Sun sits in what astronomers call the galactic habitable zone, far enough from the violent, radiation-heavy center of the Milky Way, but rich enough in heavy elements to form rocky planets. Step 2. A planet capable of sustaining liquid water. Earth has held liquid water on its surface for nearly 4 billion years, an extraordinarily long time. Many planets lose this window quickly, either freezing or boiling. Step 3. The origin of life itself. Despite centuries of science, we still do not fully understand how non-living chemistry becomes a living cell. It happened on Earth roughly 3.8 billion years ago. But whether it was an inevitable process or an extraordinary fluke, we genuinely don't know. Step 4. The leap from simple, single-celled life to complex cells with a nucleus, what biologists call eukaryotes. This transition took nearly 2 billion years on Earth. 2 billion years for one cellular innovation. That alone may be an enormous filter. Step 5. Multicellular life. Step 6. Sexual reproduction, which dramatically accelerates evolution. Step 7. The emergence of intelligence. Step 8. Language, tools, civilization. Step 9. Industrialization and technology. Step 10. The ability to leave the planet and survive as a multi-world species. Each of these steps is an opportunity for the filter to operate, for something to go fatally wrong, for the ladder to end. The more hopeful scenario is that the Great Filter is already behind us. In this version of events, the universe is full of planets with the right conditions. Simple life may even be relatively common. But something in the early stages, the origin of life, or the transition to complex cells, or the emergence of intelligence, is so vanishingly improbable that almost nothing makes it past. We did. Against extraordinary odds, on this particular rock, the right sequence of events occurred. And that rarity is exactly why the universe appears silent. There's some evidence that supports this. The transition from simple prokaryotic cells to complex eukaryotic cells, a step that took nearly 2 billion years on Earth, may only have happened once in our planet's entire history. A single endosymbiotic event, one bacterium absorbed by another, creating the mitochondria that power every complex cell alive today. If that event was a genuine one-in-a-universe occurrence, then the filter may well lie behind us. And we are, in a very real sense, the winners of the most improbable lottery in existence. This possibility is strange and humbling, but it is also, in its own way, a relief, because the alternative is much harder to sit with. Now consider the other possibility. What if life is not rare? What if simple organisms emerge readily across the universe? And what if complex life, even intelligence, is not uncommon? What if dozens of civilizations have reached something close to our current level of development? And what if they all went silent? In this scenario, the great filter lies ahead of us. At some point between where we are now and where we would need to be to become a truly multiplanetary species, almost every civilization fails, destroys itself, or is destroyed. The candidates are not difficult to imagine. Nuclear war. We came closer than most people realize. During the Cuban Missile Crisis, a Soviet submarine commander named Vasily Arkhipov refused to authorize a nuclear torpedo launch, a decision that may have prevented global nuclear war. One man, one decision. That was the margin. Climate collapse. A civilization that industrializes rapidly alters its planet's atmosphere. If the feedback loops become uncontrollable before the species develops the technology to manage them, the window for advancement closes permanently. Engineered pathogens. As biotechnology advances, the barrier to creating extraordinarily dangerous organisms drops. A civilization that develops genetic engineering but not the wisdom to control it may not survive the transition. Artificial intelligence. Perhaps the most discussed filter of our current moment. A species that creates a superintelligent system before it understands how to align that system with its own values may find itself facing something it cannot control. What makes this so unsettling is not that any one of these threats is certain. It is that a civilization only has to fail once. Here is something that has stayed with scientists for decades. If we were to find evidence of past life on Mars, even microbial fossils, most people would consider that a triumph. Robin Hanson argues it should terrify us. Because if life arose independently on both Mars and Earth, then life is not rare. And if life is not rare, the filter is almost certainly not behind us. The silence of the universe would demand a different explanation. The more life we find out there, the more worried we should be about our own future. That is one of the strangest sentences in science, but the logic is sound. If the great filter lies ahead, then whether humanity survives it is not predetermined. It is a choice. Becoming a multiplanetary species is one form of insurance. Taking seriously the danger of our most powerful technologies is another. The Great Filter asks us to consider that the universe may be littered with the ruins of civilizations that believed, as we do, that they had time. We are the only known species in the universe asking this question. That alone seems worth taking seriously. I'm the Fermi Hour. Subscribe, and next week we ask whether everything you experience might be a simulation.